Alright, so here's for metric measurements and conversions. Here's the handout you received. This is what I like to do. I like to make a line to box in my base. Alright, so you will have noticed that base units are represented by a B. That means I have kilo base, hecta base, deca base, deci base, centi base, milli base, micro base, nano base. Okay, so what is base? A base is the base unit that we're working with, such as meter, liter, gram, second, and all those other bases that you've worked with before. Alright, so let's do question number 1. Again, like in dimensional analysis, the first thing I'm going to do is I'm going to rewrite what it tells me. I have 1,000 centiliters. I'm going to multiply by a fraction. In the previous video, I knew the conversion of days and years and minutes and seconds, but I don't know the conversion between a centiliter and the regular liter, but I can always find it. So centiliter, CL, is right here. So centiliter is equal to 10 to the negative second, or it states that in 1 liter there are 100 centiliters. So, like in the previous one, I want to cancel out like units, so I'm going to say centiliter, right? Noting that the B for base is for liter. And I want to get liter, so I'll write liter there. In 1 liter, there are 100 centiliters. Well, when I was in grade school, they taught me that if I wanted to divide by a 10 and I didn't have a calculator, I could cancel out zeros. So not only can I cancel out centiliter, I can also cancel out 2 zeros. So my answer is going to be 10 liters. That is to say that 1,000 centiliters has 10 liters. Let's try number 4. Number 4 is a little bit more complex, because number 4 states that 2 centimeters have to be converted into nanometers. Well, centi only has an equation to the base, the liter, and nano is only, again, reference to my base. So this has to be a 2-step equation, just like the one with time, the one with the years and seconds, etc. So the first thing I need to do is get rid of centimeters. And the only way I can get rid of centimeters is by going back to meters, my base. Well, now I have meters, so I can go to nano. Now that I am in meters, I can go to nanometers. So I can cancel out the cm and I can cancel out the m, and I'll be left with nanometers. Okay, now we get to plug in numbers. I know, because the sheet tells me, that in 1 meter I have 100 centimeters, and again that in 1 meter I have 1 billion nanometers. 1 times 10 to the 9. That's scientific notation. If you don't recall scientific notation, there will be more videos about that. Alright, so what I learned in 8th grade was that if I have something with an exponent and I can get the same base here, I should do that. So I know that I have a decimal there, and I can move the decimal 1 2 times. So I would have 1 times 10 to the second. Alright, so that gets rid of my 100. So now I have 1 times 10 to the second, which is the same thing as 100. And now I can work with my exponents without dealing with any extra zeros. So, I also learned in 8th grade that if I have exponents to the same base, and I'm dividing, and I don't have a calculator, I can subtract. I can subtract the top number, I can subtract the bottom number from the top number. So I would have 9 minus 2. And I'm not fancy at math, so I'm going to use my fingers, and 9 minus 2 equals 7. So I would have 2 times 10 to the 7th. Why 2? The 2 is being multiplied by 1, so it's remaining a 2. It's being multiplied by 1, so it's remaining a 2. It's also being divided by 1 and divided by 1. It is still 2. 2 times 10 to the 7th. Let's try another one. Number 8. Number 8 starts with 8.9 grams. Gram is my base. Luckily, I do have my bases here. So, I have to find microgram. Micro is here. Microgram is 1 times 10 to the 6th. So I know that gram has to go there because that's where gram is. So if I have something in the numerator, I have to have it in the denominator so I can cancel out. Now I'll write microgram. In 1 gram, I have 1 times 10 to the 6th micrograms. So now, I have 8.9 times 1, that's 8.9, divided by 1, that is still 8.9. And because the exponent, the times 10 to the exponent, is considered something separate, I can do that. No math involved.